Hi everyone, my name is Siam Dangwal and welcome back to Physics for Cause. In this particular video, I will be going to explain you about the Kepler's laws of planetary motion. Basically, this video is a simulation of Kepler's laws of planetary motion by Fact Colorado Education. Kepler gave three laws. The first law states that every planet revolves around the sun in a closed elliptical path, which is an imaginary path obviously, but it's a closed elliptical path and it makes the sun at one of its focus. If we want to see the simulation, here is the result that the planet is revolving with a velocity v vector around the sun in a closed elliptical path. This is not a perfect circle, this is basically an elliptical path. If you want the target orbit for a Mercury whose orbit is very near to the sun, this is the result. If you want for the Venus, this is the result. And if you want for the Earth, this is the result. Here you can completely see that the factor eccentricity is being involved. Eccentricity is driven by the relation C upon A. Here, the value for C is 0.50 astronomical unit and the value for A is 1.50 astronomical unit. So this is how the simulation of first law takes place. Moving towards the second law of Kepler's states that every planet sweeps out equal areas in equal interval of time. In this particular screen, you are seeing the swept area in the left hand side, which is basically a graph between area versus period divisions. And in the center of your screen, you are seeing that at the center there is a sun and a planet is revolving around the sun with a velocity v vector. And the elliptical path is being divided into 4 different segments and the simulation looks like this. That in each sector it covers equal area in equal interval of time, which can be seen in the swept area in the left side of the graph as well. This is how the simulation takes place and this is how the second law is being stated. Moving towards the third law of Kepler, third law states that the square of time period is directly proportional to the cube of semi-major axis of the elliptical path. Here you can completely see that at the center of your screen there is an elliptical path whose semi-major axis is denoted by the symbol small a, and a planet is moving with a velocity v vector around the sun as an elliptical orbit, in its elliptical orbit. So the time period for the revolution of the planet is being driven by the relation that the square of time period will be directly proportional to the cube of semi-major axis, that is A. So this is how the simulation takes place in this particular relation. So if you want to see the all laws combined, this is how we can see that a planet revolves around the sun in a closed elliptical orbit or the path, making sun at one of its focus. The second law states that every planet sweeps out equal areas in equal interval of time. And the third law states that the square of time period of the revolution of the planet is directly proportional to the cube of semi-major axis. So these are the three laws of Kepler's laws of planetary motion, and I hope that you must have enjoyed this particular simulation. We'll see you in the next video. Thanks a lot for watching this particular video. See you in the next one.